All right, if you're deep in the trenches studying for the architect registration exams, you know that concrete can be a real beast. Today, we're going to untangle two of the trickiest details you'll face on your PPD and PDD exams: control joints versus construction joints. Let's dive in.
So here's the game plan. We'll start with why concrete is so high maintenance to begin with. Then we'll introduce our two main solutions, do a deep dive into each one, pit them head to head, and then wrap it all up with the ultimate cheat sheet you're definitely going to want for exam day.
First things first, let's talk about the concrete problem itself. Before we can really get why these joints are so brilliant, we have to understand the fundamental challenge. I mean, why can't we just pour a giant, perfect slab of concrete and just call it a day? Well, it really boils down to two things. Two fundamental truths about the material and, the actual process of building with it.
Okay, first up, you've got the shrinking problem. As concrete cures, it's losing water, and as it does that, it shrinks. This creates all this internal stress that has to go somewhere, and usually that means ugly, random cracks all over your beautiful slab. Second, there's the logistics problem. I mean, let's be real, you can't pour an entire building in one shot. It's just not possible. You have to stop for the day and start again tomorrow. So you have these two totally separate problems that need two totally separate solutions.
And that's where our two heroes come in. Please meet the control joint, our official crack manager, and the construction joint, our logistical coordinator.
And this slide really boils it down, doesn't it? A control joint is basically you, the architect, looking at the concrete and saying, listen, I know you're going to crack. So if you have to do it, you're going to do it right here on this nice straight line I made for you. You're managing the material. A construction joint, that's all about logistics. It's simply a planned stop. It's saying, okay, we're done for today. Let's make sure that when we start tomorrow, the new pour connects perfectly to the old one. All right, let's zoom in on our first type, the control joint. This is the one that's all about taming concrete's wild side, anticipating and getting ahead of that pesky shrinkage problem. So, here's the key takeaway. We are not preventing a crack. Let me say that again. We're not preventing it. We're controlling it. By cutting a groove, we're basically creating a weak spot on purpose. We're giving all that stress an easy, convenient path to follow. So the crack happens exactly where we want it to, in a clean, straight line. Which makes sense, right? That's why you'll also hear it called a contraction joint. Honestly, the best analogy I've ever heard for this is a perforated line on a piece of paper. You know exactly what's going to happen when you pull it. It's going to tear cleanly, right along that dotted line. A control joint does the exact same thing for a giant concrete slab. You're just telling the crack where to tear.
So let's walk through the process. The fresh concrete gets poured. As it starts curing, those internal shrinkage forces start building up. Then, before they get too strong, we come in and saw cut a shallow groove into the surface. And then, when the stress finally becomes too much, bam! The concrete cracks, but it does so invisibly right underneath our perfect little groove. Mission accomplished.
Okay, this is a big one. A number you absolutely have to burn into your brain for the PDD exam. That groove has to be deep enough to actually do its job. The non-negotiable rule of thumb is that the groove must be at least 1/4 of the total slab thickness. If you go any shallower, you're just asking for trouble, because that crack might just ignore your tiny little groove and pop up somewhere completely random.
Now, switching gears to the PPD exam, you gotta think like a planner. Where do these things go? Well, for aesthetics, you want to align them with your column lines to keep things looking clean and organized. For spacing, a good rule is about 24 to 30 times the slab's thickness. And this is critical. You're aiming for panels that are as close to square as possible. Long, skinny rectangles are bad news because they don't distribute stress evenly. Okay, let's shift gears and talk about our second joint. We're moving away from managing the material's internal drama and into managing the real-world realities of a construction schedule. This is all about the planned pause.
So a construction joint isn't there because the concrete is shrinking. It exists simply because you had to stop pouring. Maybe it's the end of the day, or maybe one part of the building had to be poured before another. When you come back the next day and pour fresh concrete right up against that old hardened concrete, that interface, that seam is your construction joint. You'll also hear it called a cold joint because the first pour went cold. I mean, this says it all, right? It's literally the pause button for your concrete pour. The line where you hit play again the next morning, that's your construction joint. Simple as that.
Now for the PDD exam, the details here are absolutely everything. Remember, you're basically gluing two separate pieces of concrete together, and you need them to act like one solid structural element. So how do you do that? Well, you can use a keyway, which is kind of like a tongue and groove joint in woodworking. It physically locks the two slabs together so they can't shift up or down. You can use dowel bars, which are smooth steel bars that span across the joint and transfer shear loads from one side to the other. And if keeping water out is a priority, like in a basement wall or a tank, you'll embed a flexible water stop right in the joint to create a permanent waterproof seal. And back to planning for the PPD. Since this joint is a potential weak spot, you can't just stick it anywhere you feel like it. You have to be strategic. You need to locate it in areas where the structural forces, like shear and moment, are naturally at their lowest. For a simple beam or slab, that sweet spot is often in the middle third of its span. This is definitely a conversation you'll be having with your structural engineer. All right, we've met the players, we've seen what they can do. Now let's put them head-to-head in a final showdown to really lock in these concepts and clear up one last bit of common confusion. This table just makes it so clear. Look at the purpose: control versus connect. What's the cause? One is shrinkage, the other is the construction schedule. See the pattern? One is about the material, the other is about the process. One is just a shallow groove, while the other is a full depth seam. And for the PDD, know your keywords. For control joints, it's 1/4 slab thickness. For construction joints, it's keyway, dowel, water stop. And here it is, the final boss of joint confusion, the expansion joint. Please do not mix this one up with the other two. A control joint manages tiny cracks within a single piece of concrete. An expansion joint is a whole other beast. We're talking a complete physical gap that separates entire chunks of the building from each other. Its job is to absorb massive movements, like the whole building expanding and contracting with temperature or moving during an earthquake. It is a totally different animal. Okay, we have covered a ton of ground. To pull it all together into one neat package, here is the final summary. So get your phone out, get your screenshot button ready, because this is the distilled, pure knowledge you need for the exams. All right, let's lock this in one last time. Control joints, they're for shrinkage. Your PDD keyword is 1/4 slab depth. Got it? Construction joints, they're for pausing and restarting a pour. Your PDD keywords are keyways, dowels, and water stops. And finally, expansion joints, they're for major building movement. The key detail is a physical gap. If you can just master the why behind each of these, you'll be in fantastic shape on exam day. And that is our deep dive into concrete's kryptonite. Now that you can tell a groove from a seam, the real learning begins. So here's a challenge for you. The next time you walk past a construction site, or even just look at the sidewalk, try to find these details. See if you can tell them apart. Being able to spot them in the wild and know their purpose is a massive step on your path to getting licensed. Good luck with your studies.